I'm going to model solving exponential equations by rewriting an exponent as a logarithm. In teaching this, I always get to do this in 4 steps. My first step is to isolate the exponential term. Then I want to rewrite the exponential term as a logarithmic. Then I'm going to solve it, and always I have to check my answer. For example, if I had 2 to the x power is equal to 7, well, that term's already isolated. There's nothing around the 2 to the x power. There's nothing added to it. There's nothing subtracted from it, nothing being multiplied. So I can go right to the next step and rewrite that as a logarithm. So I would have log base 2 of 7 is equal to x. From there, I'd put that right in my calculator. Log base 2 of 7 is equal to 2.807. And it goes on. Typically, I round to the nearest thousandth, 3 decimal places. I would check that, and I have already checked that, and that is correct. Another example would be if I had 3 multiplied by 5 to the x plus 1 is equal to 8. Make that 8 a little bit nicer. The first thing I have to do is get rid of the 3 in front of the 5. Those 2 are being multiplied, and I want to get this 5 to the x plus 1 to it by itself first. So I'm going to divide both sides by 3. That leaves me with 5 to the x plus 1 power is equal to 8/3. And I tend to keep my fractions there. It's a lot easier. I don't have to go to my calculator and keep checking what things are. Now this term 5 to the x plus 1 is isolated. There's nothing around on the outside, so I can rewrite it as a logarithm. I would have log base 5 of 8/3 equal x plus 1. Log base 5 of 8/3 is just a decimal, so I'm going to go ahead and write that in here. X plus 1 is equal to 0.609. To solve that for x, I would just subtract 1. So I'd have x is equal to negative 0.39. Check that by putting it back into the original equation, and I've already done that, and it's correct. Give one more example. Ten to the 2x plus 3 minus 4 is equal to 7. So I look at 10 to the 2x plus 3 as my exponential term. So I have to get rid of this 4. I'm going to add 4 to both sides. So I'd have 10 to the 2x plus 3 is equal to 11. Now my exponential term is isolated, so I can write it as a logarithm. Since this is a base 10, it's going to be a common logarithm. So I'd write log base 10, I don't need to write the 10, of 11 is equal to 2x plus 3. I'm going to find what that number is. So log of 11, I'm going to replace with 1.041. 2x plus 3 equals 1.041. First thing to do is subtract the 3. So I get 2x is equal to negative 1.956. I'm going to divide that number by 2, and I get x is equal to negative 0.979. And once again, I would check that. I have already done that, and I know that that works.